All right, so welcome to the Raleigh Software Craftsmanship community. We here care about delivering high quality software and finding better ways to um to be software engineers and build maintainable code. And been doing some online meetups for uh last 5 months, and we're gonna bring that to an end. Just doing a little experiment, doing it online, but we want to reach more of the developers around Raleigh, so we're gonna go more in-person meetups starting next month. So if you are in the Raleigh area, come out and hang out with us next month. And yeah, I'm very interested to hear what Alex is going to talk about today. I am currently a consultant working for a bank, and it is very bureaucratic and very brittle, complex systems. So I'm sure I'll have a lot to I'll learn a lot from today's talk here. So Alex, you can take it away.
Thank you very much, Stephen. Hi, everyone. I'm very honored to be invited to present here to this community. I didn't get much chance to learn about what this community is all about, but I'm sure there will be some discussion after some of the ideas I'm going to be presenting here. I just wanted to give a bit of a disclaimer. Everything I'll be talking about here today is nothing new. It's kind of old as hills. Um, Everybody here probably who's attending has already heard all these concepts. What may be interesting here is um, after years of practice, I've gathered this opinion that there's an advantage in looking into how bureaucracies operate and then seeing if we can apply that to our practice. Now, of course, anytime I mentioned this in the past few weeks, when I was talking to friends and colleagues, that I was invited to give this talk. And by the way, this is a new presentation I never presented before. It always raises eyebrows. Everybody says, like a bureaucrat, are you sure? Like bureaucracy is bad. Why would you want to even think about, pulling in bureaucratic mindset into software development? Software is a creative discipline. It's very dynamic. It's very exciting, and bureaucracy is a drab, mind-numbing, and everybody was like, "This doesn't make any sense." But I will try to. I will do my best today to explain what am I thinking of, why am I making those comparisons, and I'm again open to being persuaded not to go that route. So during this presentation, I would like to invite anyone to just interrupt me and ask questions or make corrections. I'm not claiming that I am 100% set in this line and I'm charging ahead. This is more exploratory. So I would appreciate your participation, especially because, as I was talking earlier with Stephen, this is not going to be a whiz-bang presentation with a lot of, animation and a lot of like sexy slides. Is going to be pretty drab and bureaucratic with just text, maybe a few pictures. So I'm afraid there's a fear that I may put some people to sleep. So if that starts happening, let me know. I'll try and come up with some jokes to bring more incitement. But for now, I'm going to slowly charge ahead and explain where am I coming from. And please interrupt me at any point and we can talk. So let's see, how do I... So first about me. I have started developing software professionally in 1990, so almost 34 years ago. And in those 34 years, I made all possible mistakes along the way. My worst mistake is this one, to measure once and cut once. And moving along, I want to say that, in my opinion, history of human species is the history of technology. In the early pre-technological days, every human generation lived pretty much the same way as all previous human generations. That is similar to how animals live. So as some species does not get extinct, each generation lives the exact same lifestyle as any other generation of the same species. But we humans, we are different. We are not like animals because we are prone to inventing things that our ancestors never dreamed about. And we do it by focusing on technological advancements. That's pretty much history of human species, is the history of technology. So famous philosopher Alfred North Whitehead said, civilization advances by extending the number of important operations which we can perform without thinking of them. It's a very interesting, and I find it very captivating quote. So the question is, how do we perform important operations without thinking of them? And I think the answer is that we outsource those operations. Sorry, going back. So, for example, let's say I want to book a flight. I can do it two ways. I can, there's an organization that does that, a travel agency, or there is the automated process which utilizes machines. So I can either go to a travel agent, or I can log on to Expedia or some such site to book a flight. Well, basically two ways. One is we outsource into the human organization, other one outsourcing to machines. And of the two, automation appears to be more cost-effective, and hopefully it's more predictable and more convenient. That's how we bought into the things such as self-serve at Expedia. And it is for that reason that the progress of our civilization always seems to lean toward more automation. So as we see, as we progress, there's more and more automation. Okay, but the problem with automation, it implies rigidity. Why? Because to be able to automate some process, we need to make sure it's repeatable. If it's not repeatable, it's very hard to automate. And if some process is repeatable, that means it's a rigid process. And when we automate such process and we virtualize it, then any future changes to the actual process will get ignored by its automated equivalent. And that means our automation is not that useful in the long run. It may be useful in the short run, but as soon as the underlying actual process changes, well, our automated virtualized equivalent stops working. And we all know that there are precious few things in this world that don't change. Most of the time, what seemed like a solid, unchangeable thing quickly turns into a moving target. So this should not come as a surprise when I say that automated systems in use today are expensive to maintain. They're also expensive to build, but that's not the end of the story. Automated systems need to be constantly modified to accommodate the unstoppable onslaught of the changes that occur in our world. You probably heard the formulation that we live in the so-called VUCA world, where V stands for volatile, U for uncertain, C for complex, and A for ambiguous. So we find ourselves in such a world where everything is kind of on a shaky ground. Communication is ambiguous, things change, there's uncertainty, there's complexity, and now we're trying to automate that. It's not trivial. We see that automated systems are brittle, and there's something called digital rot, and it never sleeps. Even when we have all the ducks in a row and everything is fully automated and all that, and we think we have completely licked it, and then all of a sudden there is a call happening at 2 a.m. that the system crashed because somebody forgot to renew the SSL license or something like that, right? So SSL certification. Things happen, and we've all been through that. And basically, it's a house of cards. What usually causes the brittleness are dependencies. Because part of the system that we build depend on some other parts of the system, which in turn depend on some other parts, and so on. Such dependencies tend to harden into tightly coupled brittle surfaces, and as soon as we start applying the pressure of unavoidable changes, the brittle surface begins to crack. And more often than not, such cracks quickly turn into serious breakages. This is basically our day-to-day life in the world of high tech. I'll give you an example. And with apologies to Brian, I took this screenshot just because I thought it's really good. Let's say we've seen that some service we depend on suddenly changes. So Brian here was kind of upset because Google turned out not to be a good steward of their APIs. So there's a Google GitHub Actions /release please action API, and they renamed it to Google APIs /release please action. They did it on Friday, and it broke thousands of workflows. Okay, as if that's not bad enough, they didn't update the documentation, didn't tell anyone. I mean, that's serious brittleness, right? God knows how many businesses out there may depend on some API that just kind of willy-nilly changes and breaks everything, and nobody's been notified. And that does not only apply to third-party dependencies. There's also, I'm pretty sure you know, in-house systems where, for example, we have people who are responsible for maintaining the backend or the API layer, and then there are people who are responsible for maintaining the client or the front end. And these systems evolve at different paces, right? So if the backend team decides they need to revamp or change something, improve, and not forget to notify, or something in the process in the VUCA world did not, there was no information radiator working at the moment, that breaks the other team, and then I get woken up in the middle of the night. Hey, panic, the system is not working, everything is crashing. So that's what I'm saying. The dependencies are what's causing the brittleness and breakages. And that is a serious issue, I think, in our world. And some people, I've heard opinions that they like it because it's called job security, but I don't think it's much of a job security. But anyway, we can debate that. So the goal of good engineering is, or should be, that we should avoid situations like the one in previous slide with Google API. I think we all agree that if we are good at engineering, we will strive to kind of prevent those things and not be arsonists and fighting fires and hoping to get applauded for fixing the fire. That's not very professional. So things keep changing not only at a brisk pace, but also without us being notified of the change. That is a big problem also. Because, you know, the process is complex, and even to our best intentions, not everything gets updated at the right time. Not everybody gets informed at the right time. And then next thing you know, things start breaking. But my contention is that we cannot build robust, reliable systems if our solutions keep breaking, because previously agreed upon ways get modified without us being aware of the change. Because different systems evolve at different pace, and that's the way it should be. Not everything should be in lockstep, because that's debilitating. And they have different domains, different concerns, and different opportunities, and they should not be holding back just because they may break somebody else. So the challenge here is, how do we allow everybody to just freely spread their wings and follow their opportunities and grab whatever needs to happen without the other dependencies breaking? So question here is, how can we make future-proof automation? We've seen that we rely, the advancements or the progress of our civilization depends on automation, but that automation is not future-proof, meaning at any point in time, things can start breaking. And future-proof would mean resilient. It means we welcome change, we embrace change, we invite change, but we minimize the risk of breaking. A future-proof automated system would be a system that will not stop working as expected once the rules governing that system change. And the rules will change, we know that. Is there such system in existence today? That is the question. And my answer is yes. And I will walk you through something that's everybody's already been experienced. I recently had to renew my passport. I'm a Canadian, so here's what was happening. My passport expired, and I was about to expire actually, and I was planning a trip, so I had to renew my passport. So what are the steps that I had to take for renewing my passport? First step would be I would search online for the nearest passport office here in Vancouver, where I live. Step number two, I would travel to that office, take the bus or train or drive, whatever. Number three, I would, once I arrive in the office, I inquire at the concierge, okay, what do I have to do to, what is the process? How do I renew my passport? And then they point me at the passport renewal brochure that was sitting on a shelf, available on display. And then the step number five, I took it home, I examined it, I learned that there are requirements for the renewal, and then I followed the instructions, procured necessary photos and documents. I filled out the form, I brought it back, I paid the fee, and then I waited. And so what are the takeaways of this bureaucratic process? So to begin the process, we need to obtain the entry point. This is unavoidable. We need the address, the location of the service, of the government service for renewing passports. Once we make to the entry point, then we need to pick up the instructions found inside the office. We then need to follow the instructions printed in the passport renewal brochure and provide all necessary artifacts. Once all the instructions have been fulfilled, we must submit the request, we must pay the fee and wait for the response. And so how is this process not brittle? All the information that was necessary for successfully completing the transaction is available at the government office, which means it's applicable right now. It's the freshest information. It's nothing stale. And by making an effort to go straight to the source, I went straight to the government office. I have avoided the risk of acting based upon some stale information, and in the process of doing that, wasting mine and everybody else's time. Had I relied on some prior knowledge, because I already renewed my passport, I don't know, 5 years ago, something like that, or 10 years ago, and I could have said, yeah, I know what entails renewing the passport, and then I went through that process, I remembered, I might have missed on the latest changes in the government regulations. And indeed, those regulations change, and the criteria and requirements for renewing passport are not set in stone, which I learned by studying the freshest brochure. This is what we call piecemeal discovery. So we are in the process of discovery. It is possible to design an automated system in such ways that when the conditions in one part of the system change, the dependent parts of the system don't have to be changed. Apologies for the typo, not doesn't, but don't, because I changed that to plural. So the dependent parts of the system don't have to be changed. It is possible to design it that way. But how do we do that? And I'm proposing we emulate the bureaucratic procedure. Because in my experience, the procedure I described was not brittle. So we are talking basically producers and consumers. The government office is the producer of passports. Citizens are the consumers of passports. And in between the producer and the consumer lie the rules. And as we've seen, the rules are prone to change. The biggest challenge is how do we protect the consumers from having to learn about the rules, and then when acting on the learned rules, to find out that, oops, the rules have changed. We want to prevent that situation from happening. And in other words, how do we avoid making our automated systems brittle? So we can move this piecemeal discovery online. I've described how it happens in the physical world, offline, but let's look into online. So number one, if I'm doing this piecemeal discovery online, I would have to somehow obtain the online address of the government passport renewal service. I could do it a similar way, obtain the government physical address by Googling or looking at some white pages, yellow pages, what have you. Number two, once I get the online address, the URL, I would click on the hyperlink, which will take me to the online office, virtual office. Once in the online virtual office, I would look for the online brochure. It's a virtual brochure. When I find the online brochure, I would have to dedicate some time to study the requirements for passport renewal. Nothing new here, right? Oops, sorry. Number five is I would then obtain all necessary artifacts, i.e. 2 headshots and anything else specified in the instruction manual. Number six, I would then fill out the online form, attach the required artifacts, click on I accept terms and conditions checkbox, submit my passport renewal application, and lastly, to process the required payment before I could expect the government officials to spring into action, start working on renewing my passport. So these are the 7 steps of the piecemeal discovery online. Everybody familiar with that? No big mystery. We call this in-band process. So let me explain. All the information necessary for successfully renewing my passport was supplied by the system I was interacting with. There wasn't any need at any point during the above 7 steps for me to go and obtain additional information from some other resource. Very important. In-band process means that the information, the knowledge of what needs to be done is self-contained and self-explanatory. There's no need to seek counseling from any third party in order to be able to successfully reach the goal. I did not have to call my accountant. I did not have to call my lawyer. I did not have to go to any specialist soothsayer or tarot card reader. Everything was supplied there that enables me to successfully reach my goal. And in my opinion, you may disagree, but I think this piecemeal discovery is quite a resilient approach. By relying on information that travels with the request, the clients do not have to prematurely bond with any prior information, knowledge, instructions. The set of instructions necessary to be able to process the request is contained in the request itself. The set of instructions necessary to process the request is obtained at the last responsible moment. What does that mean? That means we are minimizing the risk of acting based on some stale information. We don't want to be deceived into spending a lot of time and money and effort only to learn, oh, you were actually looking at this old instruction manual and it just does not apply anymore. Sorry, try again. I want to make sure that when I'm acting and I'm spending money and I'm spending effort and time, that I'm actually following the freshest, most recent instructions, which are basically what we call the last responsible. That means that when the knowledge needed to process a request changes, the client does not break because it's actually discovering a new knowledge, right? A new set of instructions. Technically, we call this late binding. So to be resilient, late binding is quite important. And this is my favorite mantra that I keep repeating, and people getting tired of hearing me saying that. But anytime we have discussions and when we are like, okay, well, then we are planning to this and that. And I'm like, okay, do we have a crystal ball? Does anyone here has a crystal ball? Do we know the future? How can we be so sure? Blah, 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 right? So I like to leave things open-ended. Why? Because experience taught me that, even best plans, or what's to say, no plan ever survives the first contact with the enemy. We can have all brilliant plans, but as soon as things starts happening, everything falls apart, and we learn like, oh my God, I had no idea that this is going to come along. A case in point, back in 4 years ago, let's talk about February 2020. We had some really grandiose plans to do something, and then March, COVID hits, and nobody could have predicted what happened in March 2020. Therefore, and we never don't know what's going to happen in June this year or September. So it's very overly optimistic to just kind of charge ahead some roadmap 5 years ahead of time. As a side note, so how to deal with brittle automated systems? We pretty much know. that if we automate a system based on today's rules, it's inevitable that in the future, some of those rules will change. There's no way that everything stays put. Unless we are planning to implement a game of chess or something like that. When that happens, the automated system will break. The way we tend to deal with unavoidable breakages is to make an effort to design our automation in such ways that will enable swift and painless and hopefully risk-free future changes. So, then we have those like abstractions in our approach. We use polymorphism, interfaces. We shield from change, We come up with ways to, even though we cannot predict the future, but let's keep it flexible. So basically, we are accustomed to rolling with the punches. We have been punched in the face more than once. And if we had naively built a very, kind of rigid, sturdy system, as soon as something changes, there's a punch in the face, falls apart. Now we roll up our sleeves, and now we have to do the rewrite, and it's costly, and it kills the morale. So we, as in our profession, we are used to rolling with the punches. So the question here is, why don't we automate a piecemeal approach? So far, we've seen that piecemeal approach works well with human users. I'm going back to the passport renewal process with the government. It's a completely physical world, human interaction. I didn't have to make a career out of learning how to renew the passport. I could go in with a fresh mind, with a beginner's mind, and accomplish my goal without having to become an expert, nor having to call my accountant, my lawyer, etc. So that's nice, piecemeal approach. The question is, can machines be designed to take advantage of the piecemeal approach? Well, the problem with machines is they're rigid. And unlike humans, machines lack agency and are therefore devoid of goals. A machine doesn't have a goal. We do have goals. It is for that reason that we need to preload the knowledge describing what to do into machines. And this preloading is called programming, right? We create scripts and programs and write code that tells the machine what to do. Without that prior knowledge, machines would not be in a position to make the decision what to do next. The decision is encoded in our script, in our program. Machines lack sentience. This is the key point. And here we're talking about piecemeal discovery, but it's all tied into human sentience, whether offline or online, whether I'm going to the government office or I'm logging in virtually online into the virtual office. I am exhibiting sentience. I have goals, and I have agency to act and to decide. Okay, click here, click there, fill out this form, etc. So this is all human-driven, right? The challenge is like machines are rigid. Can they do that? And the question is, well, can we overcome the machine rigidity? It seems like a daunting, even impossible challenge to let machines make decisions at the last responsible moment. It feels risky, right? Like, self-driving cars and when to brake, when to accelerate, etc. But if we do not enable that, we will forever be stuck in the world of rigid, brittle, easily breakable automated systems that we pretty much are having today. There is, however, one way that I'm aware of that could enable breaking out of the rigidity prison, and it's called REST. I'm pretty sure everybody here is familiar with REST, but I'll just quickly go through. REST stands for Representational State Transfer. State transfer implies that a resource representation, say a passport, changes its state, for example, from expired to renewed, or from renewed to expired, or to invalid, or forfeit, or whatever, counterfeit. So the question, what is representational in there? A passport represents the citizen status with regards to them being able to travel abroad. This is the representation. If resource representation of someone's ability to travel abroad status is expired, then that status is invalid, meaning the citizen is not fit for traveling abroad. when resource representation transferred states from expired to renewed, the underlying resource, which is a passport of a citizen who is cleared to travel abroad, is updated. So how is REST implemented, now that we know what REST is? It's implemented via 6 constraints. The first constraint is client-server architecture. The second one is stateless. The third one is allows caching. The fourth one is must have uniform interface. Fifth one is a layered system. And sixth one is allows for code on demand. So just quickly go through some of those. Client-server constraint means that it's an architectural style that is only applicable to systems that are running on a network. So we cannot implement REST inside a single computer's main memory. REST describes both the client and the server as they communicate on the network. So it's on the wire, right? The stateless constraint goes like this. Every request should encapsulate all information necessary to respond to that request with no side state or context stored on either the client or server, nor elsewhere. Basically, no out-of-band knowledge needed. Everything is in-band. Everything, all the instructions travel with the request itself. It's the same as the government brochure and all the other information processes I described. This constraint ensures simplicity, which in turn ensures robustness and resilience. The caching constraint says that any future requests for the same resource representation should be cacheable, and that means that there must be an explicit information on the cacheability of responses for future requests of the same resource representation. The uniform interface constraint, probably one of the most important ones. Sorry. I will here quote Roy Fielding, basically the person who invented REST in his PhD dissertation, 2002, I believe, which was called Architectural Styles and Design of Network-Based Software Architecture. So Fielding says that the central feature that distinguishes the REST architectural style from other network-based styles is its emphasis on a uniform interface between components. In order to obtain a uniform interface, multiple architectural constraints are needed to guide the behavior of components. REST is defined by 4 interface constraints: identification of resources, manipulation of resources through representations, self-descriptive messages, and hypermedia as the engine of application state. Let's look at identification of resources. This is simple: universal resource locator, URL. Simple because it removes any possible ambiguity. Each URL is unique, guaranteed. The second constraint is manipulation of resources through representations. A single resource can be represented in many, possibly innumerable ways. It is possible to use media type to signal to the server what kind of resource representation is acceptable. Currently, we have different, but new ones can be invented, but we can do HTML, XML, blah, 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 JSON, etc. Pure text, etc. Self-descriptive messages. This one is kind of very important. My slide. Okay. Everything necessary for deciding what is possible to do must be contained in the message itself in the form of hypermedia controls. This is in-band knowledge. So there should never be the need to reach out to some user's manual or some other resource to figure out, okay, what can I do here? Client does not have to know anything ahead of time. No out-of-band knowledge is required. Hypermedia as the engine of application state, hate us for sure. It's a weird pronunciation. It sounds like somebody hates something, but I don't know how to pronounce it otherwise. It is made possible by self-describing messages. A self-describing message enables the calling client to discover what capabilities are available on the server. This is the piecemeal discovery. The calling client can then decide what action to take. It is the uniform interface of the hypermedia that provides the ability to control the state of the application, and that capability is the engine that drives the interaction between the client and the server. One thing to emphasize here, because sometimes there's a little bit of conflation and I see a little bit of confusion, is that this hateos is not the same as remote procedure call, or RPC, because we have been at large trained to implement any functionality of the app we are building by calling various procedures or methods or function blocks of code. We're calling them either locally or remotely. To call a procedure, we must know beforehand not only the location of the code that implements the procedure, but also the signature of the procedure, the API, as well as the type of the return values, if any, if not void. And since APIs are subject to inevitable change because the system evolves, it does not stay put, the brittleness is controlled by imposing the versioning of the functionality in the API. So this is how RPC works. But hateos doesn't function like that because there is no versioning of the functionality in the hateos. So that's what's different, because we are very used to versioning our capabilities. And RPC is early binding or tight coupling. Before a client code can prepare the context for calling a remote procedure, the authors of the code must know everything there is to know about the signature of the remote procedure, as well as the types of any return values. That situation is what we call early binding. So the knowledge is cemented, early bound, and it is what it is. The client and the server are tightly coupled, and that is making the arrangement brittle because it's not resilient to change. If the procedure signature or the type of the returned value change, the calling client breaks. There's no two ways about it. So now the challenge is, how can we make sure the calling client doesn't break? Because we don't want the calling client to break. There is no way for the calling client to detect that the signature or type of return values of the call procedure has changed. Only by making the call do we learn that disturbing fact. So the onus now is on the server to play nice and not let the breakage happen. And it is customary and often contractually obliging to maintain backwards compatibility by versioning the API and then eventually deprecating, depending on the window, contractual window. That arrangement, of course, increases and bloats the accidental complexity. And accidental complexity is by far the worst problem that's plaguing software development profession. That is, in my opinion, the worst thing we're always faced with. Inventory is waste. Now, sometimes this raises eyebrows, but I'm not saying that inventory is not an asset in some industries. I don't know. But in software development, inventory is always waste. Maintaining multiple versions of the same app is insanely wasteful. It's just bloating the inventory, carrying around so much load. And yet, wherever we look, we see people doing it. There's V1, V2, V3, etc., different versions, backwards compatibility, because, we want to maintain backwards compatibility. This is meaningless because time marches on, business operations grow and mature, evolve. Why are we bothering with backwards compatibility? Why are we needlessly hanging on to something that is not true anymore? So we are kind of clutching on to the past. And the reason is, I think, immature technology. Because without that, things break. So going back to hateos, it is not early binding, it's late binding. In hateos, the calling client knows nothing about the existing capabilities of the service provider, nor does the calling client assume anything about the capabilities of the service provider. So the calling client comes in with an open beginner's mind, the empty mind, and just like, let's see what happens. The calling client discovers the capabilities after it makes the call. So first, you make the call, not knowing what's going to hit you, and then when you get the response, like, okay, now let's see what's going on here. That approach is diametrically opposite from the remote procedure call approach, where the calling client must know the capabilities of the service provider before making the call, or otherwise things break. It is for that reason that in hateos, the inventory does not bloat, and the accidental complexity is kept at bay, which is, in my opinion, very desirable. Hateus therefore implements loose coupling. The calling client and the server are coupled, of course, but the coupling does not need to be tight. As a matter of fact, all that the client needs to know is the location of the capability it intends to utilize. Like me, when I was trying to renew my passport, all I need to know is the address of the government office. I don't need to know anything else. I have no idea what else is needed at that point. Even the knowledge of the location of the capability, some other capability is not coupled between the client and the server. That knowledge gets revealed to the client once the server responds to the client's call, basically at the least responsible moment. And that knowledge now is guaranteed to be the freshest. And I don't think it's possible to implement looser coupling than that. I think that's as far as we can theoretically go. So in my opinion, Hadeus actually mimics bureaucratic systems. Same as with the procedure to renew a passport. All that the client needs to know is the entry point, the first point of contact between the client and the service provider. From that moment on, the client is not expected to know, nor is it expected to memorize anything. The client remains stateless, which is a huge advantage, again, for elegance, simplicity of performance, you name it. Statelessness is desirable because less inventory, less bloat, less accidental complexity. Actually, in Hadeus, both the server and the client are stateless, which is amazing when you think about it. This is similar to how in real life bureaucracies function. They don't know anything about their clients' details beforehand, nor do they care. And the clients don't know anything about the service provider details. We want to spend least possible amount of time interacting with bureaucracies, right? Just like in and out. Okay. Nothing to see there, just get your whatever procedure paperwork done and move on with your life. Also, bureaucracies don't care about us. Nobody's losing sleep over some client. So basically, learn and uncover as they go. However, I must say here that there is an elephant in the room, and we can either choose to ignore it, but I'm going to point it out here, just to be complete in my presentation. So the elephant is the question, can machines deal with Hadeus? And there's a bit of a controversy around that, and I will discuss it shortly, and we can talk later, and you'll see what I mean. Because we've seen that hypermedia with self-describing messages and uniform interface enables human clients to piecemeal discover the capabilities of the app. Fantastic. And that's why we are today enjoying the unprecedented renaissance and flourishing of the web, of business, because of that, right? Because we can build those resilient systems, and we can do self-serve and enjoy the convenience of doing a lot of things from our bedroom, et cetera, work remotely and whatnot. That discovery seems innate to all literate humans. If we know how to read and write, to us, it's intuitive. I mean, if for the first time, I go and log into some travel agency site or what's the word, Expedia, I don't have to take a course how do I book a flight. It's intuitive. I just go like, okay, where do you want to go, etc. It's intuitive. It's self-serve, which is the beauty of it. But now the question is, how can machines intuit that discovery? Because as we've seen, machines are rigid. They don't have agency. They don't have sentience. They don't have goals. So it does seem like hypermedia is useless to machines. And I think that is the elephant in the room. Because now if we capitulate and we say, okay, well, that's what it is, then we have no other option. Going back to the brittle RPC world, remote procedure call, where we need to know a lot of things ahead of time. I want you to meet Carson Gross. I don't know if you ever heard of HTMX. Carson is a brilliant guy. I think he's a thought leader in the field of software architecture. I had few pretty longish sessions with Carson recorded. It's available on YouTube. I can send a link if you're interested. Carson you can learn so much from Carson. Amazing guy. And his creation, which is htmx.org, seems to be taking the world of web development by the storm. Maybe it's an exaggeration, but a lot of people are talking about it, and his book is doing well, and he's been really active and overall fantastic guy. Follow him if you can. I can maybe post a link later. Good guy to follow. And one reason that his HTMX can drastically minimize is popular is it can drastically minimize accidental complexity. And a lot of people are discovering that they, instead of having to build a behemoth of React front end, they can just go with HTMX and just kind of really lean, slim, small footprint, easily maintainable solution that does pretty much the same as you would do in React. So yeah, okay. This is a plug for Carsten. Let's see, I'm trying to advance. Okay. So Carsten argues that HEIDIAS is only applicable to human users, and he wrote this back in 2016, 8 years ago. But he says, HEIDIAS is actually a simple concept. A server sends both data and the network operations on that data to the client, which has no special knowledge about the data. This simple but powerful idea has been lost because it is typically examined in terms of machines and APIs rather than in terms of humans and HTML. Humans are uniquely positioned to take advantage of the power of HEIDIAS in a way that machines are not yet because humans have agency. So Carson claims that HEIDIAS is wasted on machines. There's an essay, I linked it here. And there's a screenshot where he argues the following. But what I am convinced of, and what I hope to convince you of, is that HEIDIAS is largely wasted on machines. HEIDIAS is for humans. So in my opinion, that is a missed opportunity. I respect and I admire Carson, and I know where he's coming from, and I understand what he's talking about. But still, I would argue that this is if we were to capitulate and say, HEIDIAS only left for humans, I think we're missing on a significant opportunity. Yes, we can give up. We have tried this and that, and it's not easy. And if it was easy, everybody would be doing it. But I'm, in a way, here pretending to have a crystal ball, and I think maybe we are closer than we think, hitting the diamonds. But who knows? So, can machines process hypermedia? Without the ability to parse and process hypermedia, any calling client code is only safe if it's tightly coupled to the already tried and tested version of the app. Otherwise, it breaks. If that's the case, our attempts to avoid brittleness and bloated inventory are defeated. We cannot help but resign to those flaky, brittle remote procedure calls, which is what Carson is advocating. But I have a slightly different angle to that. I'm just trying to load my, in my opinion, that is not necessarily true. There is no reason why machines could not parse hypermedia and detect in the self-describing messages what is the next available capability or capabilities of the app. And the question is how to process self-describing messages in programmatic way. Because we humans process them intuitively. We are literate, we can read, we can recognize images on the screen, we know what affordances are, we can see that I can click here, I can push this button, I can drag this slider, blah, 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 right? I can pull down this menu. This is all intuitive to us. Machines, not so much. The only way to programmatically process self-describing messages is, I think, by severely constraining the domain of the client code. General purpose client code ain't going to do it. Server apps are never general purpose systems. They're always narrowly focused on some business domain. There is no general purpose system in existence today. A client wishing to interact with such services needs to be properly equipped with the knowledge about the domain. However, clients need to be equipped with knowledge that, however, clients need not be equipped with the knowledge that describes how is the business domain functionality implemented. That's not something the clients should care about. Unlike general purpose hypermedia clients, business domain clients have narrow focus. So a general purpose hypermedia client, basically we're talking web browsers, they possess no domain knowledge. Web browsers are not opinionated. They're like databases. You can put, database is not opinion. You can put any value into the string or character or whatever text field. It's not going to complain. It's going to say, no, I'm not going to store that. Same as with web browsers. They know how to present any resource representation they receive from hypermedia servers. They render it for us. They are the tools we humans are using to interact with machines. But web browsers have no idea, nor do they care about the meaning of the resource representation. That's not something they worry about. They just show you, and now it's up to you to either leave it or interact with it. Browsers don't care. Web browsers indiscriminately interact with any hypermedia server, regardless of the domain that the resource represents. So they're not going to be opinionated, and I refuse to load this page because I disagree with the content. Clients implementing HEDIA's functionality are narrow purpose. If a client wishes to interact with a hypermedia server, and by client I mean a program, a machine, the client needs to limit that interaction only to a clearly defined business domain. We need a concrete example to illustrate that because I feel like I'm losing you here. Let's look at a simple example. I'm going to really keep it idiotically simple because we don't have the time here. This is not the workshop. But let's say client posts an HTTP GET request in the context of, I want to book a flight. So to do that, first the user who wants to book a flight needs to obtain out-of-band information, which is the online location of the airline booking service. So let's say we find that it is online host airline.example.com. And to initiate that piecemeal discovery interaction, the system can send HTTP GET request to get//flights/book. Okay, so far this makes sense. I guess everybody can follow. So once the server receives that request, it crafts the response. It's called HTTP response, sends it back. And that response contains hypermedia controls. And those hypermedia controls prompt for more information. For example, the HTML form, which will ask or enable the input of necessary details, the departure and return dates, the departure and arrival airports, and millions of other things that we can, is it a one stop or I don't know, the price range, etc. Kosher meal or no kosher. Now the client submits the HTTP post request, which contains a payload, which the payload is the departure and return days, the departure and arrival airports, etc. And that payload gets processed by the server. Now, the server responds with available flights. Because the server says, okay, you gave me the departure, the arrival, you gave me the date ranges, you gave me this and that. I can go and craft and tell you what's available within those parameters. Here I'll be showing only one flight because real estate is limited. So the response may look like this. The collection of flights, and the first flight here is flight number 12345. The departure date and airport will be June 1st this year from YVR, return on June 21st from Charles de Gaulle Airport. The return ticket would be $1,850, the currency Canadian dollars, and there will be some links here to book, more details to upgrade. So this is the response that the client receives. So, sorry, going back here, we see that there's a rel attribute, and I want to explain, it's important. The role of the rel attribute. The rel attribute specifies the relationship between the current resource representation, which we've seen here, and the linked resource capabilities. So here we see, if you look at the bottom with a collection of links, currently, this resource representation contains 3 capabilities, and they're related to, the href, the link. So in the example, the current resource representation would be the flight 1, 2, 3, 4, 5. And 3 linked resource capabilities would be to book the flight, to get more flight details, to upgrade the flight. So maybe we want all of a sudden to buy business class or to search for business class. And from this, the client learns what is the current resource capable of. So then let's say the client books the flight 1, 2, 3, 4, 5. The client code would then activate this link, HTTP, whatever, airline example.com flight /12345/book. So what's going to happen then is the server is going to respond by sending back the form with, credit card payments, etc. We'll skip those details. The client can then fill out the form, the code can fill out the form and submit. And the flight gets booked successfully. Suppose now the client sends another HTTP GET request to the server by saying, all right, give me the flight 1, 2, 3, 4, 5. So the syntax is get /flight /forward 1, 2, 3, 4, 5. The server responds with kind of similar thing. We have the same dates, same price, etc. However, notice that in the links collection, there's no more book link. Now it's the thing that is available is cancel booking, because it's meaningless to offer to book a flight that's already been booked. However, there may be a reason why somebody wants to cancel that booking. So this capability is now exposed, which is a new capability, which the client did not know exists beforehand. They had no idea because there is no API swagger, or user manual where all these capabilities are listed. Why? Because those capabilities change and their syntax changes, is prone to change, is liable to change. So the interaction between the client and the server is dynamic, as we've seen. Clients need not know in advance that the server has the capability to cancel booked flights. That capability is only exposed to the clients if the flight has already been booked. Similarly, many other changes to the server functionality get exposed to the clients at the last responsible moment. This is lazy loading or late binding or loose coupling, which guarantees the information is fresh, is applicable now, today. So by looking at this very, very simplistic example, we can ask ourselves, can business domains produce agency? Unlike humans, machines possess no agency. They have zero sentience. Narrowing the focus increases the chances of enabling machines to make correct decisions regarding what is the next appropriate action given the business context. So large language models and machine learning can contribute quite a lot toward that goal. And specialized GPTs are showing lots of promise. I don't know if you guys are toying with these things, but it's, we can teach machines to do a lot of kind of sophisticated processing, providing that we give them a crisp, clear domain, and we can train them to automate a lot of things for us. I've been doing some GPT, actually using the OpenAI API with GPT-4 programming, and you can do a lot of good things for us. But these are still early days, of course. What I'm seeing is that the field is dynamic and definitely not showing signs of slowing down. It's accelerating. So in summary, and I'm sorry to take so long to get you there, but this is what I hope you learned. What makes bureaucratic systems resilient, and why should we emulate them when developing software? There are 2 characteristics of bureaucratic systems that I think make them robust and resilient. The first characteristic is statelessness, and the second one is apathy. Designing automated systems to implement statelessness and apathy, i.e. lack of eagerness for details, is the only way to achieve true loose coupling. As we've seen in Haitius, the interacting components of the system, the clients and server, they are not really keen on learning the details. They're kind of like, okay, we'll cross that bridge when we get there. And so nobody's keeping huge inventory of like, oh, here's a big Swagger document, and I'm aware of all these millions of capabilities and verbs, blah, 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 right? So everything is discovered piecemeal, which means there's a lot of apathy built into the system. It's lazy, it's not concerned too much about the details, and it's stateless. So true, in my opinion, true loose coupling is absolutely necessary for making our systems future-proof. I think if we are not big on loose coupling and we like to everything tightly couple and cement things, yes, we may accomplish system behaves exactly as we want it to behave, it's performant, but is it future-proof? I'm skeptical. Because I've seen many, many situations where eventually starts breaking, and then it becomes a nightmare to keep up, to roll with the punches. So thank you very much for listening. And if you have questions, I'm open to try and answer. Over to you, Stephen.
Is my mic working?
Yeah, we can hear you.
Yes, I have a question. So, since you're a seasonal programmer, how do you feel about the open software and the open source being more important in the future with the rise of AI and things that if they were closed source, it can cause a lot of problems.
Sorry, what causes a lot of problems? I missed that part.
Oh, like the AI and a lot of the events like code that I feel like should be at least majority open source because it's a lot of like sensitive stuff that it's dealing with.
Yeah. Okay. Um, I've been toying a lot with AI and ChatGPT. In my opinion, and this is just my opinion, its weakest aspect is writing code. I'm not too impressed with its current capabilities of writing code. It's phenomenal in many other areas, and I don't want to get into that. Very useful and amazing, but interestingly, it just doesn't impress me too much with writing code. However, it's really great. Now, this is again my opinion at reviewing code, the already produced code that we have created, and then suggesting improvements. And you can ask it like, hey, here's some code. Can you review it? Can you also tell me how would you improve its security? How would you implement the solid principles, et cetera, et cetera? Then it's pretty good. But just creating code, I was never impressed with. Either the test it creates or the code it creates. In my experience, yes, it creates all kinds of code, but then I have to go in and I have to inspect everything and I have to make sure everything. And by the time I'm done, I could have done it much better on my own, right? So I think it's not mature. This is just my opinion, and I'm not claiming this is necessarily coming from a lot of research. It's just kind of my impression that I think it has ways to go before it can generate good code. I hope that answers your question.
Yes, kind of. I mean, like using AI to make code is kind of like weird because like it kind of like jumbles it up, but
Yeah,
it like looks good, but it doesn't actually work. But
yeah, yeah.
like I
Mhm.
can see how AI, like if it's closed source, can be used as like a more of like a advanced algorithm to, do other things, not necessarily code.
I agree with you. I totally agree with you. And keep in mind, the AI learned how to code by looking at our code, and a lot of our code is pretty shoddy and kind of messy, right? So it reveals the teacher, the shortcomings of the teacher. But I would not recommend at this point, I would not recommend using AI to generate code. I think it's better if we craft code manually. Maybe we can ask it to review, give us some suggestions. That's great. But I don't think it's mature enough to just tell it, let go over there and write all the tests and code. I'm not convinced that's the case.
Yeah, the best product I've seen is I haven't used it, but Code Scene, Adam Torhill, he's got this kind of like ID refactoring using AI, and that seems pretty good. But that's also not for generating code.
Yeah.
I think it's
It's
the way I've used it, it's really good. Like you got some legacy code or some code you don't understand, having it like describe it, or yeah, suggestions for refactoring. It's pretty good.
Yeah, I mean, it's pretty good. It's pretty good looking at the already produced code
Yeah.
and can code, right? But again, don't use it to generate. Maybe it will get there later, but I don't think it's ready now.
And I think a big problem with that, because we have so many junior developers coming in to our profession all the time, that you need to learn how to code yourself before relying on
Oh yeah,
AI to do it for you. And I think we should spend more time doing that.
oh yeah, yeah, definitely. Any other questions?
So what's your experience with working with Helios? I've only used it with one other team. And I'll describe the kind of use case on this. It's like for the mobile app was the client, and so we would like send the mobile app different links, and based on that is for health insurance. So based on that, like they have different plans and different things that show up in the app. And I thought it was done in a very good way, and we were able to make these dynamic changes without having to break the mobile app. And I really like that. But that's my only experience with it. So I was curious to hear about yours.
I think it can be very useful in organizations, kind of medium or larger size, where you have various departments moving at evolving at different pace, and then things break because these guys over here learn that okay, they are planning to make the API look like this, and there's a Swagger document, and they build a front end based on that. But then in the meantime, under some pressure, these guys change something and it starts breaking. And so having the clients be less tightly coupled and be more like in a piecemeal discovery mode, and instead of ahead of time expecting this URL, exact URL to be the way to accomplish this capability, be open to grab the latest, like I described here when you're booking a flight, and not be preordained or opinionated about how do we actually go to that. Because it's usually these links, or not usually, always, these links are basically HTTP GET methods, right? And that's where things break when you change the signature of HTTP GET for whatever reason. And so one advantage is that you get out of this versioning hell, which is like millions of versions, and now, oh, you call the wrong version. We tested, it seems to not to work. Why is it breaking? Oh, because you're testing the wrong version, etc. Right? So that simplifies things, but it requires, like I said, very narrow domain, so that the meaning and the context of the code is very restricted. It's not open-ended. Because unlike human users, we can cope and roll with the punches. You go into a brand new website and you can quickly grok and understand, okay, well, this is what capabilities are. I can do this, this, and that. If something goes wrong, you know how to backpedal. But machines don't have that, right? So that's why I mean, it's applicable if the business domain is very constrained and restricted, and the context is clear. Then we can implement this kind of bureaucratic approach, which pretty loosely coupled, and the decisions are being made at the last responsible moment. And then we avoid the overarching documentation and the swagger and all these complications.
Yes, I have.
Oh,
Oh,
yeah, go ahead.
oh, I have one more question.
Mhm.
So, how common is Linux use in your field? And as a young programmer, should you know how to use it properly?
So should you know how to use what?
Linux.
Linux. I think it's good to know any dialect of Unix and the philosophy of Unix, the worse is better approach. And there's something called, also interesting thing, I don't know if you ever heard of Taco Bell programming. Anybody heard of Taco Bell programming?
No, what is that?
No? It's part of the worse is better philosophy, Unix. So urban legend has the Taco Bell, whatever they have on menu, they generate that item by only having 6 ingredients or something. So it's like extremely limited ingredients where you can kind of build whatever you want, right? And that philosophy then in the Unix world, that with piping and all that, you can kind of accomplish amazing functionality just by being adept at Unix/Linux commands and kind of piping the commands, and there's some amazing examples in Linux. What phenomenal functionality can you just accomplish on the command line? Which, if people didn't know that, they will have to write beefy applications and maintain the code. Because again, one Unix philosophy, I think, which I do subscribe to, is code is a liability. While functionality is an asset, code is always a liability. So less code is better, right? And so Linux is, I think, moving towards teaching people towards accomplishing a lot with a little code. But today we're seeing the opposite effect, the snowballing, the bloating, the proliferation of code. You look at those beefy, overarching React and all the like huge frameworks. It's really a huge inventory people carrying around, and it's so hard to maintain and hard to grow, hard to keep in your head. But if you learn Unix or Linux, then you can do a lot of things just on the command line. And I think that's kind of awesome. I'm not saying
Yes.
it's, yes, go ahead.
Yes. Because I got on Linux probably like a few years ago, and accidentally, like, I learned how to do things that like I didn't even know I could do, like set up my own browser, server, things like that. And all I had to do was just type in the command line. Also, it's very clean compared to like say like your average OS where, there's like a lot of stuff pre-downloaded that like people like that's like you can't install.
Gotcha. Yeah, no, totally agree. Again, I point back to one of the statements I made. Accidental complexity is the public enemy number one in our profession. And by accidental complexity, what I mean is complexity that is not necessary. It could be avoided if with sufficient knowledge and competence. And if I build something and it has a certain level of complexity, and then a more experienced colleague comes along and has a look, and it happened to me a lot of times, then they go and they prune it down and chop it down and make it way simpler and more elegant and easier to maintain. Why? Because they're more competent than me, right? And what they did is they eliminated accidental complexity. They said, "Oh, Alex, you don't need this, you don't need that, you don't need this. Why do you need this? Get rid of that," right? You can accomplish the same thing with much simpler means. And this is something I think we should be striving in our profession to get there, because then our not only for various reasons, but one of the main reasons, our job becomes more pleasant. Oh, somebody posted the talk about excellent complexity. Oh, nice, thank you.
Yeah, that's JB Rainsberger, Agile,
Okay.
7 minutes.
Oh, yeah. Excellent. Yeah, thank you very much for that. Yeah.
That's a good one.
Yeah, I basically, my experience, anytime we have serious problems involved and all that, we can trace them back to accidental complexity. This is something that's not easy to avoid. It's
Yeah,
not like doing it on purpose. It's just a lack of knowledge, a lack of competence.
yeah. JB describes it as essential complexity. The problem is hard. Accidental complexity. We suck at our jobs.
Exactly. Yeah, I agree. I mean,
Yeah.
every domain has its essential complexity. You cannot whittle it down. You cannot make it simple. This is, rock bottom. Now, starting from there, when you're implementing it, we really don't want to add more complexity unless it's absolutely necessary. But back to the question, if we have this Linux or Unix mindset, then we will be thinking about code not being an asset. Code is a liability. So we avoid, if at all, if I can help it, I would not write a line of code. If I can accomplish functionality by using existing, whatever it is, components and put them together, way better than me writing code. Because code needs to be maintained, and it's a pain in the ass, right? So
Yeah. Yeah, I mean, I would, in my opinion, I would say learn enough Linux and Unix to, know your way around it, and definitely like uh, know that philosophy. But I would definitely look into, if you are doing OO languages or functional program, like learn those paradigms, learn how to build modular systems. Because when it comes time for code to change, you want to be able to have code that your colleagues can read and understand, and that you can work with more. So. That's been my focus for the last half of my career. After I started to make things work, then I started to figure out how I can make things more readable and understandable and maintainable.
no, that's great advice. Thank you.
All right, I'm gonna stop.